Good morning, children. This is Aisha again. So, in my last video, I taught you about the chemical reactions of metals and nonmetals. We learnt about the electropositivity nature of metals and electronegativity nature of nonmetals, the reaction of metals and nonmetals with water and with oxygen. And today, we will learn about the reactions of metals and nonmetals with salt solutions. Let us begin. Coming to reactions with salt solutions. These reactions can be called as displacement reactions. I hope we learned this in our lower class, 7th class. So where we have done one activity of iron nail, dipping of iron nail in copper sulfate solution. Do you remember, children? What happened to that new shiny iron nail when it was dipped in copper sulfate solution? Yes, it changed to what happened? That the copper brown color deposit was observed on the shiny bright nail. So this is a reaction explaining that activity. So when an iron nail is dipped in copper sulfate solution, you see that the blue colored copper sulfate solution changed to pale green color, indicating the formation of iron sulfate, and brown colored powder got deposited on the surface of the nail, indicating the presence of copper. So this is called as displacement reaction because here a more reactive element is displacing a lesser reactive element from its compound, and it is occupying its place, forming a new compound. And you can see that the copper is just released or removed from its compound. So this is called as displacement reaction. Now you'll get a doubt that how will you know which element or which metal is more reactive than the other. For this, you need to have an idea about the metal reactivity series. So here is the metal reactivity series. Can you see, children? You need to know all the names of these metals. And as you can see over here, this is the order of decreasing reactivity of metals. You can see that the reactivity decreases when you go from top to bottom. Children, I want all of you to write down the names of these elements. I have given you the symbols here. I want you to note down the names of all these elements. You can see that K. What is K? It's potassium. So the potassium is the most reactive metal. So when you go down the series, you will find platinum, which is least reactive. So from this, you can understand which one is more reactive. So let us go back to our example now. Zinc and what are the two metals that are reacting here? Zinc and copper. So where is zinc? It's here. And where is copper? It's here. So you can see that the copper is much below zinc. So what does it mean? Which one is more reactive? Yes, zinc is more reactive because it is on top of the metal reactivity series. It is on top of copper. So zinc, whichever metal is on top, that is more reactive. So zinc is more reactive, and that is the reason why zinc is displacing copper from copper sulfate. Can you see here? Zinc sulfate and copper. So in the similar manner, copper and silver nitrate. Can you see now again? Let us go back to our metal reactivity series. Where is copper? Here. And where is silver? Here. So can you now guess which one is more reactive? Yes, it is copper that is more reactive now, more than silver. So very easily the copper can displace silver from its compound, and it will occupy its place, forming copper nitrate, and silver metal is displaced out. So this display, it's a non-metals. Non-metals also undergo displacement reaction. So here is the non-metal reactivity series. Very simple reactivity series with only 4 elements. So for your level, this is enough. Fluorine, chlorine, bromine and iodine. In the similar manner, like how it is for metal reactivity series, for reactivity series of non-metals also, the reactivity decreases as you go down the series. Fluorine being the most reactive and iodine being the least reactive. Let us see few examples here. Chlorine, it reacts with sodium bromide. Now see, which two nonmetals are involved in this reaction? Non-metals. So chlorine and bromine. Now out of these two, which one is more reactive? Let us check from the non-metal reactivity series. So chlorine is here and bromine is here. So which one is more reactive among these? Yes, it is chlorine that is more reactive. So the chlorine, what happens is it's more reactive, so it will displace bromine from its compound and occupies its place. Now see, in place of bromine we got chlorine, forming a new compound, and bromine is removed out. In the similar manner, chlorine reacts with potassium iodide and forms potassium chloride, and iodine is removed because iodine is least reactive, lesser reactive than chlorine. Hope it is clear, children. Speaking about reactions with acids, it's a simple reaction where metals react with acids to form salt and hydrogen. So just remember one thing, children, already we have learned about the basic nature of metal oxides. So in a way, the metals behave as bases, and when they react with acids, they form salt. So zinc, when they react with sulfuric acid, they form zinc sulfate and hydrogen gas is released out. In the similar manner, magnesium, it reacts with dilute sulfuric acid, forming magnesium sulfate. This is a salt that is formed and hydrogen gas is released out. So there is no reaction between nonmetals and acids. The nonmetals do not react with acids. So did you understand all this, children? It might sound a little confusing to you, but please do watch the video carefully once again. You can pause the video and try and understand. Once you understand a single concept, then only just go forward. Don't simply watch the video mechanically. Try and understand. So with this, we come to the end of our first chapter, metals and non-metals. Only one small topic is left, that is uses of metals and non-metals in our day-to-day life. And I'll be giving you as an assignment. This as an assignment. You will have to jot down some points regarding the uses of metals and non-metals. Thank you.